Alright, hello again, welcome back. We're going to go ahead and get started with the locomotion part of the tutorial now. So similar to what we just did in the gesture tutorial, we're going to go ahead and log on to Mixamo. We'll download a new walking animation that we want to link to our Remy character. And we are going to give him some freedom, that way he doesn't have to stay linked to that one spot on the grid. We'll allow him to pace back and forth between 2 points of interest on a key press by the end of this tutorial here. So go ahead and open up the Mixamo website again. And this time what we're going to do is go ahead and type in walking into the search bar. It's going to pull up all sorts of crazy animations, but we want something fairly normal for our Remy character. But it doesn't matter, feel free to choose anything you want. For this, we're going to go ahead and pick the first one on the list, and it's going to load this animation onto our character. There's one more thing that we want to check before we download this, and that is to hit this in place button. That's going to make sure the animation is not actually moving the 3D model and that he's still tied to the same place. It will make things a little bit easier for us when we set things up in Unity. So after you've checked that, go ahead and hit the download button. Again, we want the Unity for FBX for Unity in the format, and then we want without skin on the skin option because we do already have that model downloaded. So then you go ahead and hit download. I'm going to hit cancel because I've downloaded these ahead of time. And you want to go ahead and save those to the assets/3D models folder, just so that we know where to find them. So now, just like we did with our waving gesture, we need to add this as a potential animation on our animator controller. So go ahead and hit the animator window, or if you don't see that window, go ahead and hit 3D models in the project tab, and go ahead and scroll down to your Remy controller and double click that. And then, just like we did with the waving animation, what we want to do is find that Remy at walking asset and go ahead and just drag that up there onto the grid. So we know we want our walking animation to be a looping animation, so go ahead and click right click it, hit make transition, and click itself again. That way when he walks, he's going to continue playing that walking animation until we tell him to do something else. So at this point we have an isolated animation over here that does not trigger back to that idle animation, and I'll show you how we get it to trigger back here in just a few minutes. So I'm going to go ahead and save. Next thing we want to do is go ahead and set it up. That way we can trigger that walking animation on a key press, just like what we did with the waving animation. So go ahead and make another new C# script. Click in the project tab, hit scripts, right click, hit create and C# script. This time what we're going to name it is Locomotion Control. I did code this up ahead of time, so my script is going to look slightly different than yours when it pops up here. Alright, so you should be able to see. Mine is full, but what we want to focus on right now, on the slides, we're going to fill in these three lines in the start function. So go ahead and write that. The Remy anim equals get component animator. That grabs that animator component from the Remy model. And then the next thing we want to do is make sure that our inverse kinematics work from Nahal's part of the tutorial. So we want to go ahead and add this line here. What that does is just make sure that that we can turn the inverse kinematics off when Remy's facing the other way, otherwise we'll get some weird warping of our 3D models. The next thing you want to go ahead and code is in the update function. Go ahead and make that if statement just like we did in the gesture part of the tutorial, where if input.getKeyDown.keycode G for go, is triggered, then we're going to go ahead and call a public function called the walking signal. So I don't have the walking signal shown up here on the slides, but I will show it here on the side in my code in my editor. Basically what we want to do is have another if statement inside this public function, and we are going to look at if the isWalking variable is triggered, then is not triggered, I'm sorry, Then we're going to head and deactivate that inverse kinematics, just like I mentioned. We don't want to trigger those weird warping. Then we call our animation component, and we're going to hit play for our walking animation. And again, this has to match whatever animation you downloaded from Mixamo. So if you downloaded one that says run or something different, make sure you plug that in here correctly. We're going to go ahead and hit make this is walking variable true. And you're also going to want to add this as a global variable up there. You can see them at the top in the slides. I just didn't mention that. So make sure you add in those 3 variables in addition to making the changes to your start function and your update function. And then these 2 lines of code, don't put those in just yet. So you can go ahead and either, if you've already put them in, go ahead and comment them out, or just don't type those in if you haven't already. Next up, we'll code our else statement, and just so that we're clear here, I'm commenting these out. So hop down to your else statement. We're going to do the same thing. We're going to make sure we reactivate our inverse kinematic script when he's done walking. We want to set is walking to false, and then we want to have our remi_anim.play idle animation. So this will automatically call that idle animation and play it when we're done walking. So instead of doing it through transitions in that animator controller, we're doing it through explicit script calls in the script. And then again, this last line, we're not going to worry about that for right now, but we'll get to it here in just a second. So don't write that one in just yet. All right. So now when you go ahead and open up and press play, oh, no, we're missing a step here. So the last thing we need to do, similar to what we did in the gestures section, we need to link this script to Remi. That way he knows what he's doing. So go ahead and drag that Locomotion script up onto the Remi character in the hierarchy. Okay, so now when you've made that link onto the Remi character, we have our Locomotion script there. We should be able to go ahead and press play in the editor. Hopefully you do not get any errors down here. And what you want to do is go ahead and click inside the game window, go ahead and press G, and you'll see that he does indeed start his walking animation. But he's not going anywhere, so we still need to do that part here. So go ahead and click stop, and we'll go ahead and give him some points to walk between. So next, what we want to do is make 2 empty game objects. These are just going to serve as kind of holders for a set of coordinates. So go ahead and right-click inside the hierarchy window, hit create empty, click the name there so that we can rename it. We'll name one of them point A, and then we'll go ahead and duplicate that one by just pressing Control D, or you can make another one using the long way if you want. And then we'll name this one point B. So when we've got both of those, you'll see they're just invisible components. Go ahead and click on them and reset their positions back to 0, 0, 0. And then when you get to point B, we want point A to be at 0, 0, 0. We want point B to be at 0, 0, minus 10 in the transform window. So go ahead and click point B. Look up there in the top right corner. You should see the word transform in its inspector window. And then for the Z value, we'll go ahead and put minus 10. What that does is it sets up 2 points behind Remi. So we have one that's right under his feet and another that's about 10 meters behind him. So we'll hit save. Next thing we need is to set up a ground plane for Remi to walk on. This is necessary because we are making, we're going to use nav mesh to make his walking behavior more realistic. So go ahead and click not cylinder. Go ahead and right click in the hierarchy, hit 3D object, and we want plane. And it may put it in a weird spot. Go ahead and hit the inspector window and bring its position back down to 0, 0, -8 is where we want this one. And then we're actually going to scale this one up a little ways too, that way he has room to walk. So the scale we'll put to be 1, 1, and then 2 in the Z direction. That way we get this nice long plane for Remy to walk on. So you should see something like this. Next thing that we're going to do is turn this into a nav mesh. That way Remy will know how to navigate around on this little ground plane. So this window is usually kind of hidden, but if you go into Window up here, then down to AI and Navigation, it will make it pop up if you don't have it. So go ahead and click that. It's going to bring up this panel with 4 tabs: Agents, Areas, Bake, and Object. What we want right now is the Object tab. We're going to go ahead and hit Navigation Static. And make sure that before you press this, that plane object is selected in the hierarchy. So hit Navigation Static. We do want it to be walkable, so we'll just leave those settings as they are. And we'll click back over to the Bake tab, and we'll hit Bake. So when you do that, you should be able to see this little blue rectangle appear on the mesh, which is exactly what we want. That shows the walkable area that Remy can navigate on there. So the only other thing we need to do here is to add another component onto Remy that is a nav mesh agent. So these are pre-written Unity components that just take some of the legwork out of it for us. So go ahead and select Remy in the hierarchy. You're going to have to click back over to the inspector window from the navigation window. And what we're going to do is hit Add Component at the bottom. And if you type in nav, it should be the first thing that pops up, Nav Mesh Agent. So go ahead and click that. We can look at the settings for it here. We are going to leave everything at default for the moment, although there will be a couple of parameters that we can adjust to our own specifications here at the end. Agent type, we do want him to be human. Base offset is how far up the collision detection goes for him, so we want that to be set at 0. And then what we want are all these default values for right now, but we'll come back and we'll actually adjust the speed and the angular speed on him when we have this running. So go ahead and save your progress. And then one other quick thing I want to do before we get into the scripts is I don't like having to look at this plane out here. So what we'll do is go ahead and click it in the hierarchy, and then in the inspector window you should see this Mesh Renderer tab. We can go ahead and uncheck that. So it still has our navigation information baked into it. It's just not visible, a little nicer on the eyes. But you don't need to do this if you prefer to have that. You can go ahead and leave that there. So next up, we're going to need to make a couple more edits to our Locomotion script. So go ahead and open up that, open up your code editor. And first thing we're going to do is add a couple variables to the top. So I've updated my script, that way it has all of these sections commented out for us. And you want to add in all of these variables that you see up here on the slides. And in my case, I'm just going to uncomment them. So we'll go ahead and do that. And again, if you don't want to write all this code, that's perfectly fine. If you open the scripts folder, you should have your own pre-written final version of this script. So you can copy and paste this into your other script, or you can just go ahead and use this and save yourself a step. Next thing we want to do is in the start function, we want to add these 3 lines about the point A position and the target position, point A, B, and the target position. So I'll go ahead and uncomment those in my code here. Basically what this does is it takes those 2 invisible points that we just set up, and it's going to raise them up to Remy's height. That way when we tell him to walk towards those points, it doesn't angle him weirdly. And then the target position is going to be the point that Remy is directed to walk towards. So we're going to initialize that to be point B, which is super far behind him. And when we get closer to point B, we're going to go ahead and reset that to point A. That way he turns around and walks right back to where he was at the beginning. So when you have that, go ahead and go down to the update function, and we are going to add in a bunch of code here. So we want to add this conditional statement looking at if Remy is walking, then we do want to check the distance. So we make a float distance, and we check his current position to the target position. And then we see if that if that distance is less than the variable we call proximity, which we set up at the top. So we could make this value anything we want. We just want to make sure that he gets close enough to that point before turning around to come back to his next point. This next block of code, we see if toward B equals true. That is if he's walking towards target B. Then we tell it to switch to target A, so we set toward B as false. We set his new target position to point A dot to his transform position. And then the last thing that we do is the Remy agent. We do Remy agent dot set destination target position, which is set to that point A position. So that makes the nav agent target this new point A. Else statement is the exact opposite. So this means that he's reached point A again. He's started from A, he's reached point B, and he's come all the way back to point A. So we want to go ahead and reset our variables toward B equal true, target position equals point B dot position, Remy agent we just set back to this default position of point B, and then we call walking signal again to turn it back off. That way he doesn't continue to walk in place once he gets back there, or continue to pace back and forth between these 2 points. Alright, so when you go ahead and caught up there, there's just one other part to add that you will not see in the slides, but I will show you in the code editor here. So if you scroll down to the walking signal public function, and I have an error here somewhere, I'm missing an indent. Nope, I am missing a close bracket. There we go. Alright, so if you go back down to this walking signal, those 2 lines we mentioned to ignore earlier, we want to go ahead and uncomment those now. So if you wrote them in and commented them, go ahead and uncomment them. Otherwise, go ahead and write them in now. So what we want is this Remy agent dot is stopped to be equal false, to put in the not is walking conditional. And then we want a second line that says Remy agent dot set destination target position. So basically, if he hasn't been walking when this function is called, we tell him to walk, we set up the destination for him, and then we tell the nav agent to go. The else conditional, we just add one line down here at the bottom, which is Remy agent dot is stopped equals true. That'll make him just halt in his tracks wherever he is. So go ahead and save your changes to this Locomotion script, and then we're going to go back to our editor. So if you click on the Remy agent, what we're going to see is in the Locomotion control script, there are a couple of public variables. So for point A, we want to drag point A from the hierarchy window over here into that empty public variables place. We do the same thing for point B, and just go ahead and drag that one over. And then we'll leave walk speed and proximity set to their default values. So it should be fine. So now when we press play, and we press G, we're going to see he does turn, he does walk all the way back there towards point B, and then he comes all the way back towards where he started. And we can go ahead and repeat that if we would like. But looking at this, we know there are a couple things that are still a little weird. So when you first hit G, you see him make kind of that sliding transition. And then when he reaches that point in the back, he also makes another kind of sliding turn. And these things can be adjusted by going into the inspector window of the Remy character. So go ahead and hit Remy in the hierarchy, then hit the inspector window, go down to nav mesh agent. And we want to change his speed and his angular speed. So if we set his angular speed to maybe twice what it is right here and test that, that's much better. You see he turns much quicker. The sliding effect is less noticeable. It's still a little noticeable. So I'll try a little bit faster. Well, that's pretty good. I'm not going to spend too much time on that here, but you guys definitely need to adjust your speed and your angular speed for the scale that you're working with for your application. Otherwise it will look like these agents are kind of ice skating over the ground instead of walking. So you need to make sure you get that pretty close to correct. So we'll go ahead and halt the Unity play mode there. And we're going to continue on with the next section of the tutorial here in just a second. Now, if you've been following along since the beginning and you did Nahal's part of the tutorial, you will notice you will have a canvas object in your scene. So in the Unity scene, you will have this canvas object, and then if you switch to the game view in Unity, you'll already have all these buttons set up. So this makes this part so much easier. But just in case you haven't, this section of the slides also has how to set up this canvas and how to set up buttons on their own too. So I'm going to skip over that part since we've all been watching since Nahal presented. And all we're going to do is add the buttons for these parts that we just did. So go ahead and click the canvas in the hierarchy window. Go ahead and open it by hitting the little triangle. And you see we have all of these different buttons in here from Nahal's part of the tutorial. You're going to right click canvas, and we're going to go down to UI, and we're going to go down to button. So there's one. We'll go ahead and name this one wave. And then we'll go ahead and Control D, duplicate that, and we'll name this one walk. So we'll go ahead and hit the little triangles next to these. Those open up the text components of these buttons. So to change the names back to wave and walk, we just go ahead and hit the text component, and we go over to the inspector window where it says button, and we just change that to match the function of the button. So we'll do that for both. This one is going to be walk. And you can see the default position where it put these is right over Remy's face, and that's not where we want it. So what we want to do is hit that wave button first. We'll go ahead and do that one. And then you want to hit the translate or move tool, and you want to make sure you're in scene view. Now setting up a GUI in scene view is a little weird because it makes things huge in the editor, and then your actual scene is very small. So if you double click, that will get you pretty close to the component you want to change. So go ahead and double click that wave button, and then if you use the scroll wheel on your mouse, you can move pretty quickly as well. So go ahead and move the wave button in line with all of the other ones we've made here. I'm not going to worry about being exact. And then go ahead and get that walk button aligned just reasonably well as well. So we'll put those all underneath there. And that's looking pretty good. So we've got our buttons, but right now they don't do anything. To make these link to the functions that we coded in that gesture script and in the locomotion script, we need to go into the button logic here. So what we'll do is hit the waving one first, hit wave in the hierarchy. We'll go down to the button script, and you can see it has this part where it has on-click events, but it's an empty list. So we'll fix that. Go ahead and hit the plus icon, and you'll see it brings up this little window where you can link a game object. we want to link our REMI object to that link. So go ahead and drag REMI from the hierarchy into the slot. And then in the function, we're going to look for our waving control script, or whatever you called it, if you named it something different. And we'll go to that public function that we made, which was wave signal, if you've been naming everything just like we have. It is important that that function is made public, because if it's not public, we will not be able to find it on this list. So if you made that private by mistake, make sure you open up that script, change that keyword to public, and resave it, and it should pop up over here. So we've got our waving signal set up. We need to do the same thing for our walking signal. So go ahead and hit walk in the hierarchy, and then navigate back down to that on click. We'll hit the plus. We'll link our REMI object again, and this time we are going to go down. I selected the same script, so go to Locomotion control, and this time hit walking signal. So easy enough.